Advanced abstract equations, we've already done these before, but now the only difference in the ones you've done in the past is we're adding like a little sum on the top or in the denominator. That's all that really is the addition in this lesson for this concept. So it says solve for m in example 55.1. So first thing we got to do is common denominator. Well, actually, sorry, least common multiple. All right, what's our least common multiple between x and m? So it's going to be then multiplied together, xm. So we multiply everything by xm. X is crossed out here. Now we distribute the m to the a and the b. Since it is being multiplied, you got to distribute ma plus mb plus m's crossed out here. You're left with y x equals kx m. Now we're solving for m, so the next step we always had was to get the m's on the same side. Alright? Well, say variable, same side. So we got an m here, m, and these spots. So I'm going to subtract yx and subtract kxm. And basically just have them switch sides. ma plus mb plus minus kxm equals yx. From here, factor the m out, and we're left with a plus b minus kx equals yx. Now we have m on its own here, so we can divide by that. So yx, try to write it clear, over a plus b minus kx would equal m. Okay. Now they actually have a slightly different answer in the book, and what you would, because what they did was they subtracted these two to this side, and for some reason it gives a slightly different answer on that problem, but it really should be the same, so you really don't need to worry about that. Let's look at the next example. Let's see, mx over y plus d over a plus b equals p, and solving for a. Well, our least common multiple is where we start, and that is, remember, a plus b is its own identity, so we have to multiply y times a plus b. Y times a plus b as our least common multiple. So we do that to all these spots. Y is crossed out there. Got to distribute mx to a and mx to b, so we get mxa plus mxb. Let's see, we got y times a plus b here. Nice that those cross out, so plus yd equals py times a plus b. I'm going to go ahead and distribute pya plus pyb. And then second step, same side for a. Here's an a, and here's the other a. We're going to subtract these and subtract pya. That leaves me with mxa minus pya equals pyb minus mxb minus yd. That's where we're at now. Factor out the a. And you get that equals all of that. And just to save time, I'm going to divide by mx minus py. Again, just go ahead and do that to save time. We didn't go through the steps. You should understand from that point, but if you don't, rewind to the last example. But that is how you do advanced abstract equations. Now let's look at, in addition to one word problem we've done, consecutive integers using quadratic equation. So we've done find 3 consecutive integers before. And we know that that means n plus 1, and n plus 2. And when we did that, this is our first, second, and third. Such that the product, okay, so now we have something a little different. We're using products of these. So the product of the first, product means multiply, n times, and the third, n plus 2. So the product of the first and the third is, so equals, 4 greater than 4 times the second. So plus 4 is at the end, since it's 4 greater, than 4 times the second. And that's where we're at. Now we solve. Got to distribute the n, get n squared plus 2n equals 4n plus 4 minus 4. Those cancel. That's awesome. Lots to deal with. So then we are left with then we are left with, sorry, I lost my place in the book. Oh, those don't cancel. I don't know what I was doing. Okay, confused myself. 4 times 1 is 4 plus 4. I think I wrote minus 4. So these add to be 8. So we do have the extra number to deal with. Does that have to be 8? My bad. Once again, team, I'll take that one. Subtract 4n. From here, we want to get everything on the same side, and I'll show you why. We got n squared minus 2n, subtract 8, minus 8. Now, there's nothing over here. Nothing on this side of the equal sign, so it's equal to 0. And we've seen this before, using generally the x for the letter. But now we have n squared minus 2n minus 8. Okay, can we factor this? Does anything multiply to be negative 8? It's a quadratic equation, by the way, but does anything multiply to be negative 8 while adding up to be negative 2? Well, positive 4 and negative 2 would be an example, or what it is. So n plus 4 times n minus 2 equals 0. Now from here, we have 2 separate equations that we create. N plus 4 equals 0, and n minus 2 equals 0. And then we solve for n. Subtract 4 and add 2. So we get n equals negative 4 and n equals positive 2. Is that your answer? Not quite. You're close. But it said 3 consecutive integers. So the consecutive integers for these would be 2, 3, and 4. And negative 4 plus 1, negative 3 plus 1, negative 2. So you have 2 sets of consecutive integers that would be possible. And that is how you do those word problems. And that is the end of lesson 55.